What we're going to talk about here is finding outliers. And an outlier is an extreme value that is much more or less, or it is much greater than the normal data. Kind of like if you went about taking a test, if someone scored really good or someone scored really bad, you wouldn't want to really include their average or their score into the overall average. We'll kind of look at that compared to the number of people, like Dr. Berger said on the last example, on how many times a car goes through an intersection. Well, if one intersection is really busy, you don't want to use that data in your overall mean score, because then it kind of pushes the mean score up a little bit higher than it should be. So we want to find out whether something is an outlier by determining what the standard deviation is. And if you go 3 standard deviations beyond the mean, that will tell you that that is an outlier score. And that's where that says that right here. If it wants to look at data values that are more than 3 standard deviations from the mean. And we'll do that. And I'm going to use my calculator this time. Dr. Berger did it all by hand. He calculated the standard deviation by hand, which you do need to do, but also go ahead and get your graphing calculator out right now. And I'm going to show you how to take the number of electoral votes in 2004 in the 11 western states. They're shown over here to the right. And I want to find the mean and the standard deviation for that data. If you were to find the mean, you'd take 11 plus 3 plus 7 plus 4 plus 3, all of those electoral votes, and add them all up and divide by the 11 states that are in there to see what the mean electoral votes are going to be. We're going to use our graphing calculator here. Okay, and the first thing that we're going to do in this graphing calculator is, as it says right here, take and, sorry, here. Okay, and we're going to enter these things into list 1. Okay, in order to enter them into list 1, we're going to hit the stat key. Okay, so hit your stat key, and we're going to edit a list. Okay, and we're going to clear all the data out, okay, here of list 1. So I'm going to clear all this data out of here. And if you have anything, hit enter after that, it clears it all out. If you have anything in list 2, go ahead and clear that out too. Hit clear right now. Okay, that clears everything out of list 1 and 2. Okay, so I go into my data, and I'm going to enter in, okay, where I have Washington had 11. Okay, and Montana has 3. Idaho has 4. Okay, keep on entering in, okay, all of the data, okay, into your calculator. Hopefully I don't enter one in wrong. You can watch here to make sure that I've entered all my data in correctly. I got 5, 10, 11, 55, 9, 5, 4, 3, 7, 4, 3, and 11. Okay, so once I have it all in there, you can go back in and you can hit standard stat, and you go over to calculate, and you can take and find all the statistical data for one variable, and that's why we just want one variable. Okay, and hit enter. Okay, and it'll tell you, okay, all what the X bar, remember X bar stands for your mean, so your mean electoral votes are 10.5. Now, I have a problem with that. 10.5, and I don't see any of them near 10.5 except for California that has 55. So how can an average electoral votes for every state be at 10.5 when only 2 of the states are above 10.5? So what this is telling us is that we have an extreme value in here, California, which is probably an outlier. And if we wanted to test to see that it's an outlier, we look at the standard deviation right here. Okay, and what we're going to do is we're going to see that the standard deviation, okay, of this thing is, okay, and if you look at the sigma, which is sigma x, that says it's 14.3. Okay, and you can see right over here on my thing, it says the standard deviation is 14.3, and it has a mean of 10.5. And we got that data from right there, okay, and from right there. Okay, and the next thing that we're going to do then is to calculate 3 standard deviations. So if I calculate the 3 standard deviations, I get a score of 42.9 electoral votes from the mean. So if I add 10 plus 42.9, I get at 53 electoral votes. So that tells me right away that California, okay, is going to be right here at 55 for California. And it's going to be an outlier. So what we'd like to do is I'd like to take and cancel out that 55. And if I cancel out that 55, I can get a better mean score right here. Okay, and you can see that right down here. Okay, I've done that already for you, and I found out that my mean score comes up to be only 6. And if we look back at the data here, you know, a lot of this data right over here that we're having, okay, for this, there's only a couple of them that are bigger than 6 and a couple of them that are smaller. So 6 is definitely a better mean score. And because of that, we have a standard deviation here of only 2.8. Okay, so that's telling us, you know, that we're having a lot better standard deviation. 2.8 meaning the smaller the standard deviation, the more clustered those numbers are together. So that's what you're going to use standard deviation for. When you have a big standard deviation, like 14.3, that's telling you that you have numbers spread way beyond the mean score. Okay, otherwise, if you have them all clustered together, you have a really small standard deviation, that means your numbers are very, very clustered together. So this is how you go about using it, your standard deviations, to find out if there's any outliers in there. All right, quickly, if you have just a quick lesson quiz, here are 5 questions. What I want you to do is hit pause right now. You can do these 5 questions. And then I have a couple of them from the book that I want you to do. The ones from the book, I'm going to add on to it tomorrow as you get in class. So if you're not taking the rest of the test in class, then you'll work on the assignment that I'm going to give you here at the end of this lesson video, as well as a couple more of them from the book to add on to it. But first, just to test whether or not you get it or not, here are 5 questions. Hit pause, and when you come back, I'll kind of give you the answers. All right, go ahead and pause now. All right, so number 1, I guess you have finished up those 5 questions. Number 1, you should have a mean score of 5.4. You should have a median score of 6.5, and the mode was 7. Number 2, okay, you should have found out, okay, that the expected value, you take 0 times 0.75, 1 times 1.5, and 2 times the probability distribution of 0.08, and you come up with the expected number of accidents to be about 0.37. Okay, so a little less than half of a accidents per week. Number 3, first thing you have to do right up here is we want to find the mean score. So if I take all those numbers, add them up, and divide by 10, I get a mean score of 1.4 or 1.41. Sorry, 1.4. Okay, then after that, I have to find the differences between the mean and each one of those values. So if I come up here and take 0 minus, okay, so I'm taking 0 minus that, 3 minus this, 1 minus that, I'm getting these numbers right there. Okay, then after that, I don't want to take and subtract all of these numbers right here. I don't want to add all these numbers up to find out my variance. Okay, but instead, I want to square those numbers first. So if I square this negative 1.4, I get 1.96. I square that. This will give me all positive numbers. Okay, and once I have all those positive numbers right there, okay, I want to find the average of those. Okay, so I find the average of those, and this will tell me what the variance is. So my average is, that's my variance, the sigma squared is my variance of 2.64. But to find the standard deviation, we want to go back to not having it squared. We only squared it up here so that we didn't have negative numbers to deal with that would change my values. So if I come up here and I square that 2.64, I see that my answers are 1.6, which is my standard deviation. So my mean score is 1.4, and my standard deviation is 1.6. And these are elevator stops. All right, and 3. Okay, on 3, I just wanted to make a whisker plot here. The first thing you did was put them in order. Okay, second thing is we found the middle score right here was 14 plus 14 divided by 2, so we have a median score of 14. Okay, I had to find my third and my first quartiles. So if I count 1, 2, 3, 4, 5, 6, 7, 8, okay, I have my first quartile is right there at 13, and my third quartile is going to be right there at 18. So I have an IQR, an interquartile range of 5. I have my extreme maximum is going to be at 23, and my extreme minimum is going to be at 11. Okay, and then I have my box with the whiskers and the median in there. And the last one up there, using my graphing calculator, I put all the data into my calculator. I found out the mean score. Okay, right up here was 5.3, and I found out my standard deviations is 4.3. Okay, so that you can see if I multiply my standard deviations by 3, I get 12.9. So I add 5.4 plus 12.9, and I get 18.3. So you can see right away that I do have one value that is an outlier. If I take that value out of there, I'll get much better data to represent the standard deviation of those scores. Your assignment for tonight, just do those 6 problems, 1, 3, 5, 7, 10, and 12.